This is a challenging final exam question for Xiaojia B, and it has stumped quite a few top students. Let's take a look at the problem. The question tells us that a and b are positive integers, and that a squared minus b squared equals 1,573. It asks, what is a minus b? Some students might say, I don't recognize a squared minus b squared. Well, this is called the difference of squares. Now, generally, for the difference of squares, like a squared minus b squared, how can I write it? I can write it as a minus b multiplied, a plus b. Well, remember that they are equal, so the result should also be 1,573, right? But why this change? Because now it's the product of two numbers multiplied together. All I have to do next is think about which two numbers can be multiplied together to get this result. It's hard to figure out just by thinking, so we can use short division. Let's do short division on 1,573. At a glance, I can see it's a multiple of 11, so I divide it by 11 first, and the quotient is 143. Next, I divide it by 11 again, and the final result is 13. So 1,573 is broken down into 11 times 11 times 13. All right, now I want to explain why I said that at a glance I could tell it was a multiple of 11. How do I determine whether a number is a multiple of 11? Let me teach you a few simple methods. For example, if it's a three-digit number, how do we judge? First, let's look at its left and right digits. The first and third digits, right? If the sum of the left and right digits equals the middle digit, then the number can be divided evenly by 11. Look, 1 plus 3 does not equal 4, which is the middle digit, so it can be divided by 11. Right? And as for the quotient, when you divide it by 11, let me tell you, you just need to remove the middle digit. See, when you divide it by 11, you get 13, right? So next, let's think about how we can determine whether a four-digit number is a multiple of 11. Let's divide the four-digit number into two groups, splitting it in the middle. The left side is 1 and 5, the right side is 7 and 3. So we have two groups. Then we subtract the outer number from the inner number in each group. What do I mean by inner number? For example, in this group, between 1 and 5, the inner number is 5, so 5 minus 1 is 4. In the other group, between 7 and 3, the inner number is 7, so 7 minus 3 is 4. If the differences in these two groups are equal, then the number can be divided evenly by 11. 4 equals 4, right? So this number can also be divided by 11. And how do we calculate the quotient when we divide by 11? Again, take the numbers on the left and right, 1 and 3, and write them down first. The number in the middle position is the difference we just calculated. So 1,573 divided by 11 is 143. Do you all understand? Next, let's write down the result after splitting it up. This 1,573. It equals 11 times 11 times 13. But that's not quite right. Why not? Because I want to break it down into the form of two numbers multiplied together. But right now there are three numbers, right? So, for example, let's multiply these two first, which gives us 121 times 13. All right, if I multiply these two, it becomes 11 times 143. What else can I do? I could say, let's multiply all three numbers together to get 1 times 1,573. Actually, all three of these ways meet the requirements of the problem. If we really want to use this data to calculate the values of a and b separately, the sum and difference problems can be solved. We won't go into detail here. But the key point is, when I split it into two numbers multiplied together, if I want to find a minus b, which of these two numbers could be a minus b? You see, a minus b is definitely going to be a bit smaller than a plus b. So among this set, which one is a minus b? Isn't it 13? In this set, isn't it this one? In this set, isn't it this one? So this problem actually has three answers. You can fill in that a minus b can be 1, or what else? Or 11, or also 13. And with that, we've finished this problem. I suggest everyone give this a like and save it to watch a few more times. Otherwise, if you want to use such a useful method again, you might not be able to find it.